Good morning, everyone. I will start my presentation now. So, I would like to thanks very much the organizing committee of ICRS 2021 for having inviting us to make this talk, which is hydrogeophysics for estimating vulnerabilities of shallow aquifer at Kuchi at the north of Ho Chi Minh City. This talk has been prepared with 3 colleagues of the Geopet faculty at HCMUT at Ho Chi Minh City. I am Marc Bécoat. I am from IG laboratory at Grenoble-Alpes University and currently working at the laboratory care at HCMUT. So, as you may know, Ho Chi Minh City could be an intermittent island in 2050. Of course, if no flood control systems are built, since that there is a pessimistic scenario, you see that they can have an invasion of the seawater around the city. And in this context, this is due to the subsidence, the groundwater pumping, as well as the sea level rise, which is producing this situation. The elevated areas will play a very important role. You see here in part of the province, you have more elevated area above 5 meters high. And those areas are very important to be protected for future needs. So, considering elevation, soil conditions, exposure to sea level rise, the urban development in the direction of the northwest of the city is much more climate proof than in the southeastern direction. We expect a direct urban development towards the northwest of the city. And we have to know also that the Vietnam government is also acting now to prevent the groundwater extraction, trying to limit the subsidence phenomenon. But if more activities are already planned at the north of Ho Chi Minh City, we could have a look to the groundwater vulnerability. So for our research, we choose a typical elevated area near the town of Kuchi with various land uses suitable for our research needs. As you can see on this picture, you have new industrial area, future industrial area, paddy fields, rubber fields, high-tech agriculture, and as well as cattle farm. So this is typical for testing the vulnerability of the shallow aquifer. So what are the treats here? You can see that disease treatment, pesticide, contaminants, antibiotics, and pollutants can be released from those activities. And the question arises actually if there is some shallow clay soils here, which can prevent the aquifer, the shallow aquifer, to be polluted from surface pollution. What are the links between the Saigon River and the aquifer? And if there are some clay layers at depth, are they continuous laterally? And does they prevent any vertical infiltration? So when we have a look to the hydrogeological knowledge in this area along this cross section here, you can see that you have many aquifers and also many clay layers. And if we zoom a little on the surface here, you see that the information gathered by the hydrogeologist here comes from separated boreholes every 3 to 5 kilometers. And in these examples, you see that there is 2 boreholes, and we can draw a continuous clay layer at the surface. And if it is the case, it is a very good point to prevent any pollution to infiltrate deeper. But they seem to be protected, but we wanted, using geophysics, to have a look to this question. So, to have a look to this question, we use a geophysical method, which is quite well known, the time domain electromagnetic methods. And this method uses the electrical resistivity, which is linked to clay and water. And you see low values of resistivity indicate clays or some with salt water. And in the intermediate range here, 200 to 500 ohm meter, you have the sand with fresh water. And above 1000, you can have also dry soils. This method uses a cable, a current flow, which creates a primary magnetic field. And when we cut the current, we induce in the ground induced current, which are also generating a secondary magnetic field that we are recording at the surface. The result of this sounding is an apparent resistivity curve versus time, and this curve can be translated into a 1D model with different resistivity and thickness. You see here the result of these soundings, which display between 58 and 68 meters deep, a clay layer and a deeper substratum at 90 meters deep. So the major advantage of this method is to be sensitive to the clay. In the study area, it is not possible to see any shapes of the ancient river at the surface, contrary to other tropical climate rivers, in dry climate here and humid climate here in Indonesia or Senegal. As you can clearly see the ancient shape of the river, oxbow, and meanders that has been cut in the past. So if we want to search such structure in the soil, we need a dense sampling of TDM survey. This is what we have done with 170 soundings, TDM soundings, and you see that the right bank of the river here has been prospected with many TDM soundings. When we interpret those soundings, we can draw some contour maps of the calculated resistivity. Here you have the example at 0 meter, and it is clear that the river flood plains here is characterized by low resistivity values between 1 and 75, and that we can draw the bank of the plain here in red color. So we can make this interpretation at various depths. From 0 meter, you recognize here the map I was just showing, going down -5, -10, etc., down to more than 100 meters. You have only 100 meters here. And you can see that the river flood plains actually is more at the southwest of this region. To make this result easier to understand, I took a simplified resistivity scale here with the blue value corresponding to the flood plains and with the black lines corresponding to the banks of the river. And I will run now a small video showing from 0 to -150 meters, showing finally the ancient position from the present to the past. Let's run the video here. You see that actually the bank is moving towards the southwest here, and at -50 and -30, the river, the ancient river, was more at the southwest. You can see channels, all channels here. At -100, you just see the position of the river, and at -30, at -130, you have seen an ancient meander. So this result is very important because we understand now more how was organized the tracks, finally, of the Saigon River, and we can have a look to the results, also with a geophysical cross-section, for example, this one, we see that here you have the clay layer in blue colors between minus 25 to minus 45 meters deep, which is not continuous. You have a small interruption here, but basically it is situated at minus 30 meters. And when we compare to what was seen by some boreholes, we see that this layer has been also seen here. But we also see that at the surface, actually, there is here a hypothetical clay layer that is absolutely not seen in geophysical results. So is there a risk of vertical infiltration of pollutants through the vadose zone? We should say that here in the southwest part of the study, yes, there is a risk because there is absolutely no clay layer that can protect the aquifer. And on the left bank here, you see that at the surface, we have a clay layer, actually, that can protect the aquifer, but also, because there is no infiltration, every pollutant that are released in this area can reach the Saigon River with the runoff. So as a conclusion of our study, we have seen that TDM electromagnetic geophysical methods allow us to identify all clay channels and banks, limits up to minus 150 meters deep. So we can see finally the ancient shape of the Saigon River, and this is a key for borehole seating and resource estimates. We have seen also that there is not always a continuous clay layer observed at the surface. So the shallow aquifer are therefore very vulnerable to pollution in some areas. And my final message is that the current and the future activities must take into account this vulnerability for future developments. Of course, for future study, we are able to estimate the groundwater resources and the pollutant threats in more details. And we are thinking about the possible extension of this vulnerability map using frequency electromagnetic methods. I would like to thank you very much for your attention. And you have some picture here of the field team doing the geophysical measurements. Thank you very much.